Hello everyone. So in this video, this is the second part of the ions video, and this second video we learn how to draw ions from the atoms. Okay, so we will first look at cation ions, right? So metals, this is a property of metals. Metals will lose electrons to become positive ions, and positive ions are known as cation ions. Right, so let's take one example, lithium. Okay, so lithium is 2.1, right? If you cannot remember how to write electronic configurations, please watch the previous video. Okay, so lithium is 2.1, so the electronic configuration will look like this, north-south and then north. So this 2.1, oh, this is not sodium, sorry. This should be lithium. And over here, this shouldn't be sodium, this should be called lithium ion. So now, we want to get a full valence shell. So there's two ways I can get full valence shell. I either lose the one electron over here, lose it to get a full valence shell, which is 2 electrons here, or I can gain another 7 electrons over here to form a full second shell. Now, it will be easier therefore to lose the 1 electron over here, right, as compared to gain the 7 electrons. So how does lithium form a full valence shell? Is that lithium loses 1 electron, and when it loses 1 electron, it has 2 electrons left. Okay, now lithium used to have 3 protons and 3 electrons. Now the lithium ion still has 3 protons. However, if you look at the diagram here, it only has 2 electrons. Now, there is 1 more proton than electron, so therefore, the overall charge for lithium is positive. Remember, it is very important to put these square brackets over here to signify that this is an ion. Okay, let's look at the next one, magnesium. Now, magnesium has the electronic configuration of 2.8.2. So how many electrons do you think that magnesium will lose, right, in order to get a full valence shell of electrons? So you're right. So over here, it must lose 2 of its valence electron. Magnesium has 2 valence electrons, and therefore it will lose both valence electrons. So let's draw it out. So we got magnesium, firstly, north-south, and then 8 electrons, north, south, east, west, north, south, east, west, and then one more circle, and then north, south. All right, and then it will lose 2 electrons to form magnesium 2+. So now I lose 2 electrons, so north, south, and over here I got north, south, east, west, north, south, east, west. The last 2 electrons over here, right, I've lost it, so I don't draw it out. Okay, I'm not done yet because ion is a charged particle, so I need to make sure I use my square brackets. Okay, make sure I use my square brackets, and then I think I lost 2 electrons, so I lost 2 negative charge. Okay, or you can think that magnesium initially we started with 12 protons and 12 electrons. Now I still have 12 protons, but if I count the number of electrons, I have 10 electrons. So I have 12 positive charge and 10 negative charge. I have 2 positive charge more. So therefore, the charge of the magnesium is 2+. Alright, so there's the metals. What about non-metals? Now, non-metals instead will gain electrons to become negative ions. And another name for the negative ions is an anion. Right? So why do they gain the electrons? So let's look at fluorine. Fluorine has an electronic configuration of 2.7. In order for fluorine to get a full valence shell, it either gains 1 electron or loses 7 electrons. Now, the gaining 1 electron is definitely much easier. Okay, so over here, fluorine, we draw the electronic configuration 2 and then 7. So north, south, east, west, north, south, east. Okay, so I have 2.7, and now I'm going to gain an electron. Now this electron will come from outside, right? So I'm going to draw this again, north, south, east, west, north, south, is this is the original electrons, and then the outside electrons come in. I'll use another symbol. I'll use a circle, right? So we can see that I have 7 valence electrons that are original and 1 valence electron that is from the outside, and that makes my full valence shell. Okay, I gained that 1 electron. Now, so originally fluorine has 9 protons and 9 electrons, right? And then the ion has 9 protons, and now you can count the total is 10 electrons. So now I have 10 negative charge and 9 positive charge. So the overall charge now is a single negative charge. Now in chemistry, we do not really write the 1, right, when writing charges. So you can look over here, lithium, we do not write 1 plus, but we write a 2 plus, right? And for fluorine, we do not write a 1 minus, right? We just write a minus. Also, do take note that we like to use 2 plus instead of plus 2. So please keep it that way. Okay, let's look at our last example over here. So oxygen, right? Oxygen has 2.6, right? So now a full valence shell will consist of 8 electrons. So 2.6, how many electrons must it gain? Right? So over here it will gain 2 electrons. Right? So oxygen originally 2.6. So 2, let me draw the 6. North, south, east, west, north, south. Okay, and then it will gain the 2, right? It will gain 2 electrons. So I have north, south. Let me draw the other one. This was how it was originally. So then I have 2 electrons. So 1 here, 1 here. Remember my square brackets. And because I gained 2 electrons, the overall charge is a 2 minus. Okay, so non-metals has a special name, right? So for here, this is fluorine, I-N-E, and then the ion is called a fluoride ion. Over here, this is called oxygen, and here is called an oxide. All right, okay, so we have gone through 2 examples each. I would like all of y'all to go back to this page over here and complete, right, all of this. And I want you all to take special notes of hydrogen, okay, because hydrogen over here is very special. Although metals lose electrons and non-metals gain electron, hydrogen is a special case. Hydrogen is a non-metal, and although hydrogen is a non-metal, it will lose the electron instead. Okay, so I would like you all to fill this up, and if you have any trouble or any question, please feel free to ask me. Okay, practice hard, all the best. Bye bye.